expanses of time over the evolutionary history of life on Earth are so vast that they're difficult to fathom. But by dividing that time into eras and periods, such as we see here on this time spiral, we can better grasp the events that have taken place here over the last few billion years. Some of these are punctuated by biological events in our evolutionary history, such as the beginning of the Cambrian period, with a massive radiation of animal biodiversity. Other time demarcations are for geological events. For example, the end of the Mesozoic era being truncated by the arrival of an asteroid.
The reason for combining the two in our story on animal evolution is because many biological events are consequences of geological ones, so it pays to know your history. So in this episode, we'll be exploring the large timescales of the evolution of life, as well as the interaction between geological events and important punctuations in the evolution of animals. Because there's a relationship between geological activity and the success or demise of certain animal lineages that will give rise to animal biodiversity over time. Life on Earth evolved at about 3.8 billion years ago with the single-celled prokaryotes. Multicelled life evolved in forms that we can recognize at about 550 million years ago.
Then there was this age of dinosaurs, somewhere between 250 and 65 million years ago. And mammals reigned after that. And it wasn't until just a few million years ago when humans emerged in the story. For humankind, our historical timescale has been a blink of the eye, relatively speaking. So it's really hard for us to be able to get our head around the massive timescales and the relative proportion of time that's devoted to the various major stages of the evolution of life. But that's going to be one of our goals here today, to address that, but also to recognize the interaction between the Earth's geological history and the evolution of life. So if we start by looking at the evolution of life on land, we recognized already that insects were the first animals to emerge from the oceans somewhere on the order of about 450 million years ago, when the Earth was already colonized by plant vegetation, and so insects quickly followed to feed on that plant life. There are many forms of fossilized evidence of plants being fed upon by insects many millions of years prior to vertebrates ever leaving the oceans. During this time, at around the Silurian period, fish evolved in the oceans. We know that one of the descendants of the fleshy-finned fish were the amphibians, who at somewhere around 400 million years ago emerged from the oceans to wander about and explore the land during the Devonian period. And by the Carboniferous period, at about 350 million years ago, the lands were dominated by tall forests of ferns and lycopods. This land was patrolled by amphibians, which would be wandering about the humid areas and would have to return to the water. The humid forest ecosystems would have been full of many different kinds of terrestrial and flying insects at the time. So life on land was a wet, humid, tropical wonderland up until about the end of the Carboniferous period. This led to the evolution of amphibia, whose name literally means a double life. And their double life is one that is split between aquatic and terrestrial habitats. So these were the first vertebrates to explore the terrestrial habitats. But they were poorly equipped to spend their entire life cycle on dry land, particularly because they had thin, permeable skin that was susceptible to drying out, or desiccation. And, of course, neither their gametes, that being the sperm and egg, nor the embryos were protected in any way against desiccation either. So amphibians as adults had to restrict themselves to humid environments or spend very little time out on land. Every now and then they had to return to water to maintain that moisture in their skin and their body. But also, very crucially to the life cycle, they were required to return to the water in order to reproduce, like these African clawed frogs do today. so that the gametes and embryos would survive, requiring the water to protect them from drying out. So this is essentially the scenario in the Carboniferous period, which is named after the huge carbon fossil stocks that were deposited from these massive forests of ferns and lycopods. And we're now burning that as coal. We'll get back to that later on in the story, as part of some of the more modern implications and repercussions of interacting with this evolutionary biodiversity story. What we know is that the world prior to about 300 million years ago was very humid. It was very lush. There was a tropical rainforest-like ecosystem across most of the Earth, and there were amphibia that were wandering around on dry land chasing insects that were abundant both on land and in the air. Then, of course, something remarkable happened at around 250 million years ago. And that was the continental drift leading to the formation of the supercontinent known as Pangaea. So what we recognize as the continents, as we know them now, the terrestrial crusts are not static. They're mobile, in fact. They move around on the Earth's surface. And they've been doing so for hundreds of millions of years. And so the positioning of the continents on the Earth right now are by no means the way that they were hundreds of millions of years ago, nor are they the way that they will appear hundreds of millions of years from now, as they will continue to move around. The formation of Pangaea had dramatic consequences for life on Earth. Around 80% of all animal species went extinct at that time in a very rapid time frame, evolutionarily speaking, on the order of just a few million years. How does the formation of a supercontinent lead to these extinctions? Well, as these continental plates become closer and closer to one another, all of the water between them, those lakes and oceans, will disappear. And so a huge amount of extinction in aquatic species occurred because of the loss of those habitats that just completely disappeared. Also, a very large extinction of terrestrial species took place because of a massive change in the climate caused by the formation of the supercontinent. It essentially created environmental conditions that led to a super hot and dry climate with a lack of inland water bodies. This was a less than ideal habitat for amphibia, which required quite the opposite. But there was one group of descendants of the amphibia that were already pre-adapted to be able to take advantage of these hot and dry conditions on land because of their scaly, impermeable skin and the fact that they were not required to return to the water in order to reproduce. We're talking, of course, about the reptiles. Much of the reptilian success at terrestriality is due to the evolution of internal fertilization, so that the gametes and embryos would be protected from drying out, as well as the evolution of the amniotic egg. This calcium-shelled egg allows the embryo to develop outside of the water without risk of desiccation. The shell is permeable to gases, so the embryo can breathe through development, but it is impermeable to water and water vapors, so the contents of the egg are not susceptible to drying out. Within the egg are nutrients to feed the embryo as it grows and develops. There are waste deposit sites to extract the toxic wastes, and not to harm the embryo through development, there are cushioning chambers filled with fluid to protect it from bumps and shocks and temperature changes. And essentially, it allows the reptiles to live completely on dry land, without having to return to water to reproduce. So, from 250 million years onwards, after the formation of Pangaea, we saw the age of dinosaurs, or the Mesozoic era, which essentially means the age of the middle animal. This is in contrast to the time prior to 250 million years, the Paleozoic era, or ancient animals, which included the evolution of all animal life forms, the sort of lineages that would give rise to fish and early vertebrates. So now, firmly in the Mesozoic era, the age of dinosaurs, in that for almost 200 million years the Earth was dominated by large reptiles that would run around eating any animal or plant that these predatory or herbivore reptiles would come across. Now this made it very difficult for any other kinds of animals to flourish. So this was an age that was dominated by reptiles alone. Any other animals that did exist had to do so cautiously and remain out of the crosshairs of these dinosaurs so they didn't become their next meal. One of the animal groups that did emerge at the time were a small group of warm-blooded animals, like this Morganocodon, that were nocturnal, highly social, and basically lived in the shadows, trying to stay away from the dinosaurs. We're talking here about the mammals, which came into being around 150 million years ago. Ecologically speaking, mammals were relatively insignificant at the time, but mammals were well positioned to take over following the demise of the reptiles that was to come. The mammals' big opportunity came 65 million years ago, in the form of a large asteroid that smashed into what is now the Yucatan Peninsula of Mexico. All of North and South America would have been immediately razed to the ground just from being in the blast zone of that asteroid. But the rest of the planet was affected too. The impact of this huge asteroid is believed to have shaken Earth so severely that there would have been tectonic activity that would have created earthquakes and volcanic eruptions. There would have been clouds of ash and dust shot up into the air kilometers high. This would have had the effect very much like a nuclear winter. Earth would have been shrouded in ash and dust for at least 5 months, plunging all of the planet into complete darkness. The atmosphere would have gone cold too, because sunlight would not have reached the surface of the Earth for that entire period of time. What that meant was that any animals that need to be mobile and use their eyesight to find large quantities of food would have perished. That meant most of the dinosaurs didn't survive this 5-month period of darkness and cold. Only animals that were capable of hibernating and demonstrating some level of dormancy were able to survive. Some subsets of the dinosaurs were in fact capable of doing so, including the crocodiles and birds being feathered and insulated against the cold. But among those survivors were mammals. Furry and crepuscular, nocturnal and already pre-hibernatory because of their need to avoid dinosaur predators. Like their descendant, this hedgehog, they were very well adapted to a life of scurrying around in the darkness, scavenging for small amounts of food. But also, not unlike many of us on a long weekend, they were able to sleep for extended periods of time and just wait it out until the conditions became favorable for them to emerge after the effects of the asteroid had passed. So when the dust literally settled, several months after that cataclysmic event 65 million years ago, most of the large reptiles had gone extinct, and it became an era that was largely dominated by the diversification of mammals. Now we're talking about the Cenozoic era, being the modern era from 65 million years ago to the present. And in many ways, it is the age of mammals. This is due to the prolific diversification that was only made possible after that 65 million year benchmark in the geological history, where the turnover in life forms was quite catastrophically imposed upon the animal tree of life, creating the conditions for mammals like these to flourish. So what we see is that from this point onward, there was a rapid diversification of many lineages of mammals, and even more so after about 45 million years ago. A key feature that emerged at that time was the development of grassland ecosystems. They were a very important habitat for mammals to colonize and diversify as well, leading to many evolutionary lineages that were very successful from the point of view of biodiversity. This includes rodents, marsupials, as well as ungulate-hooved animals like gazelles and horses that would patrol the new habitats in the world's prairies. One subgroup of mammals that is of particular importance to us are the tree-dwelling primates, climbing in the tropical forests of Africa. They would eventually give rise to a hominid lineage of proto-humans around 6 or 7 million years ago. The evolution of humans from them occurred at around 3 million years ago. The ancestor of modern humans, the Australopithecines, were forced out of their forest habitat due to climate change. This was caused by a rapid decrease in the Earth's temperature between around 3 and 2.5 million years ago. This decline in temperature caused a decrease in the forest cover, particularly in East and Central Africa, where many of these Australopithecus species existed. So essentially, humans evolved out of primates that were forced from the forest. In addition to the forest habitat disappearing on them, the number of lakes and rivers dwindled, forcing these proto-humans to adopt an upright and nomadic lifestyle out in the hot equatorial sun, as opposed to a more sedentary arboreal or tree-dwelling lifestyle in the comfortable, resource-rich, cool shade of the forest. So that led to the evolution of bipedal humans, who had lost their body hair as a means of adapting to not overheating on the scorching hot savanna. This evolution also included the development of sweat glands to maintain our body temperatures at low levels, despite the high levels of activity required for being human. These activities involved cooperative hunting in order to gain food resources for the social groups that our ancestors lived in. And so cooperation between members of the group would be very important in the evolution of our cognitive abilities. Also critically important was the development of our ability to create tools, and would allow us to manipulate and dominate our environment, leading to a decreased susceptibility to environmental pressures, thus creating a very successful species that was capable of colonizing the entire planet. Now, things really took a turn for us humans at some point approximately 10,000 years ago, when we became truly sedentary and we domesticated animals like cattle and plants like wheat. With the development of agriculture, humans became capable of producing more food than they needed. From that point in history onward, we were able to have stratified societies, with individuals having specialized jobs and the emergence of institutions like political systems and economic and education systems. And of course, these advances, in conjunction with our intelligence and ability to create technology, have led to our complete and total dominance of the planet. As you can see from all these points of light made by human habitation on Earth. Our dominion over the Earth is so intense that we are said to be in a new epoch at the moment, known as the Anthropocene, being that human-dominated age where we as humans are truly having a pronounced and unprecedented effect on the planet itself. So if we're thinking about the timeline, it's really sort of mind-boggling to think of life on Earth as being 4 billion years old. Animals themselves are barely 500 to 700 million years old. The human species have only existed for a few million years, and the timelines for human history are only on the order of hundreds to maybe a few thousand years. Those time spans are in dramatic contrast to the vast expanses of time over which the evolution of all these animal features are taking place. But despite that being a very small period of time, we've had a dramatic impact on the planet's integrity and functioning. For example, we've driven many species of animals to extinction. Most notably, many forms of insects and amphibia. Because of the use of toxic pesticides, to which these organisms are very susceptible. Amphibia are sensitive to toxic chemicals in the environment, in part due to their permeable skin, because they can readily absorb chemicals into their tissues. Additionally, they're semi-aquatic and would be bathing in puddles and bodies of water around farms where these pesticides are being applied and are accumulating. Insects are obviously the targets of many of these pesticides, so it's unsurprising that they will be affected by them. But it's also important to note that many of the pesticides used over the years have a very broad spectrum of target insects affected, meaning that they're not necessarily specific to just a single group of insects, and the beneficial ones have been eliminated alongside the pest species. Many commercial farming practices have had devastating effects on natural insect populations outside of agricultural areas that pesticides have been applied, because of the leaching, drift, and lingering effects of these toxic chemicals in the environment. Another feature of human ingenuity was industrialization and combustion-fueled mechanical work, which for the past 2 centuries has been spewing greenhouse gases into the atmosphere, causing the Earth's temperature to increase. This runaway climate change may be the biggest challenge to humanity in the next few decades, because of the unpredictable and unprecedented effects that we're seeing. There are changes in the climate taking place that have not been observed over the entire human evolutionary history, let alone any recorded in recent memory. Increases in CO2, methane, and other greenhouse gases are causing the Earth's temperature to increase and are forever changing global climate patterns. But all the while, we've also been causing extinctions due to our other activities. Over the past 40 or 50 years, almost half the vertebrate species around the world have been driven to extinction due to human-related activity. One of the main reasons for that is just simple habitat loss, of clearing natural habitat areas for urbanization, agriculture, and other human uses. One example that might hit close to home, and certainly pulls at some of our heartstrings, is seeing some of these more contemporary images of the polar bear, an iconic northern species of mammal that is truly suffering from the effects of climate change, which is causing habitat loss. It is preventing them from feeding properly and maintaining healthy diets and body weight. This is because polar bears, such as this one, require ice floes in open waters during the Arctic spring and summer in order to hunt seal, which are their main prey. Without those ice floes, they can't access the seal hunting grounds and they go hungry. This may eventually lead to the extinction of polar bears because their environment is changing faster than they can adapt. So, of course, the consequences of this, if we can't reverse habitat loss, is that many species will not be able to survive and will continue to be driven to extinction because of continued pressure from human activities. Another impact from climate change is when the natural cycles become out of sync with one another. Natural cycles that have evolved over millions of years to work for the life cycle needs of animals are no longer perfectly synchronizing with one another because of changes to the environment from climate change. One example is migratory birds, whose migration from their winter feeding grounds down south back to their spring and summer breeding grounds in the north is largely triggered by changes in daylight length, or photoperiod, which is continuously changing over the course of the year and is also predictably regular from year to year. This is because of the stable pattern of the Earth circling around the Sun. However, the food source that they're timing their arrival to find is under the control of temperature due to the early spring and summer warmth causing seeds to germinate, plants to grow, and insects to develop. Now what's happening, of course, is that those insects and plants are developing faster and earlier because of climate change. But the birds are not necessarily arriving any earlier, because their evolutionary behavioral cycles are tuned to changes in the photoperiod, which are not shifting due to climate change. So what we're finding in many instances is that migratory birds are arriving too late to take advantage of food sources, which they would need in order to complete their life cycle, such as being able to feed offspring in their spring and summer breeding grounds. So there's a lot to be worried about, and there's a lot to be upset about in the state of the world and the environment. But it's important to also recognize that we still have the opportunity to turn this around. In order to do so, we need to have some hope. So while it's important to recognize the problems, it's also important to recognize the places and ways in which we've been successful in counteracting some of the negative impacts from human activities that we've already seen on the environment. For example, biodiversity. Many of us have been hearing a lot about the decline in honeybee populations as a problem with respect to the colony collapse disorder and the loss of these important pollinators to commercial agriculture. This would certainly have important repercussions for human food production, given that about 35% of our food is under almost direct control of insect pollinators for fertilizing those plants and creating the food for human consumption. However, it's been noted that if we counteract some of the negative impacts of agriculture, for example, if we restore native habitat, reduce pesticide applications, and reduce the introduction of competing exotic, non-native species like the European honeybee, that we do see the return of native biodiversity. And that biodiversity can then supply those ecosystem services, such as pollination and pest control, for free and in harmony with the neighboring ecosystems, as opposed to having to rely on domesticated, industrialized processes, such as those that are associated with the use of commercial honeybees for pollination services in agriculture. Another success story, of course, is the emergence of all the non-carbon energy sources which are destined to be the way of the future and will allow us to break our addiction to oil, as well as to break the cycle of pollution that is leading to climate change. We will need to shift our energy sources to those renewable alternatives. The good news is that those alternatives already exist, whether we're talking about wind, solar, hydroelectric, or geothermal, and that they're all scalable, energy efficient, and that they produce energy in a way that's economically viable.
Of course, in order to turn this ship around, we're going to need more buy-in from the public and from governments that will support these new greener industries instead of continuing to support the old fossil fuel industries and to allow us to turn a corner to a greener future. Of course, one of the greatest success stories of this whole situation is the motivation of today's current generation of students who are taking charge and correcting the mistakes that have been made by my generation and the ones that have come before. You, the students, through no fault of your own, are the ones who are inheriting this problem. But thankfully, you are the most intelligent, informed, and empowered of all generations that have come before you. I see that as a good sign that there's a possible solution and that the solution is in the best hands possible. It is no overstatement to say that the action that we take in the next couple of years will define the success or failure of the entire human species and its future.